First off, thank you everyone so much for attending today's webinar. We're super excited to share some information about this very unique use case that we have at the RIPTA Broad Street Station project. I'm Dana Wasley, and I am the Transit Business Line Lead for the Mobility House. And I am joined today by Zach from RIPTA. He is one of their senior planners, and today we will be talking about their Broad Street Station project and how they are using backup power as part of their project scope. So before we jump into the use case, I did just want to give some brief background about the Mobility House and the ChargePilot system so that some of the concepts that we talk about later will make sense. So starting off with just some background about the Mobility House, we are a leader in the clean transportation and energy space. And we've been in business since 2009, so we bring more than a decade's worth of experience in fleet electrification. ChargePilot currently is deployed at more than 1,700 sites worldwide. Getting a little bit more into ChargePilot and some of the use cases that we work on. So ChargePilot has a number of different applications in the North American transit market. We have many clients that use our charging management system ChargePilot for optimizing charging around their utility rate structures, as well as to prioritize their charging around their fleet schedules. Today, we're really going to be focused on the second point here, which is this idea of being able to actively manage your charging within a set grid capacity limitation at your site. And so basically what that means is if you have a site and you are planning to install, let's say, 2 megawatts worth of charger nameplate capacity, and let's say you only have a 1 megawatt grid capacity connection, that would be what we would call an oversubscribed site. And you would have to have a management system like ChargePilot in place to facilitate what we call automated load management, or ALM. And basically what automated load management and ALM is having a charging management system in place that is able to reliably optimize your charging to make sure that your chargers never try to pull more power than what's available at your site. ALM is really an innovative concept. Traditionally, if you were in a situation where you wanted to install more charger nameplate capacity than your grid connection, you would have been looking at a capital project where you would have had to, build up your infrastructure, upgrade your transformer, add more capacity to your site to be able to move forward with your project. ALM is a newer concept that has been approved by the National Electrical Code, and I will get a little bit more into it later on in the presentation and how that applies to the RIPTA case study. But just definitely keep this in mind as we are talking today. The second piece of background information that I wanted to go over today is just a little bit of background about the ChargePilot system architecture. So I will start by talking about this piece over here in the middle, which is called our ChargePilot local controller. This is a small piece of hardware that allows us to continue to optimize charging even in the event of an internet outage. The local controller is hardwired to each of the charging cabinets that we manage at our sites, and this allows us to always have a stable and reliable connection to the chargers. This local controller is very critical to the RIPTA use case, and we'll get into it a little bit more later. So please keep this in mind as well as we talk a little bit more about RIPTA's use case and our solution. Now I'm going to hand it over to Zach. Zach is, one of the smartest, most amazing people in the industry. Our team has really enjoyed working with him and collaborating with him and his team on this project. And today, Zach's going to share some more information about RIPTA's electrification program and, how they have developed the Broad Street facility.
Thank you, Dana. And first off, your boosting might go a little bit too much. I appreciate it, but I'm merely a humble public servant, just for everyone else who is listening in. So as Dana mentioned, I'm Zachary Agish. I am the principal planner for capital development here at RIPTA. Have been an employee for 5.5 years as of this upcoming June. And I've been involved in our fleet decarbonization efforts for the most part since joining in 2019. And so just to give a little bit of background as to what ultimately led to this particular project, I don't think it's any secret, it's not even really a secret. It's a motivation by many people that we are being asked as transit operators nationwide to make concerted efforts to transition all of our revenue and non-revenue vehicles to zero emissions in a rather hastened pace. And, we're all kind of going through it at our own pace. That said, the R line originally, back in the mid 2010s, was essentially two separate routes. And the R line is kind of the agglomeration of these two routes that were each running at about every 15 minutes. So when they were combined, they could run on a 10-minute headway. And these two particular routes, which were known as the 11, which ran down Broad Street, and the 99 that ran up to Pawtucket up North Main Street, always had the highest ridership and continue to still have it even today when they were combined. And just to give enlightenment to that, it's essentially, it's not a BRT in the sense that it's fixed highway, but it's BRT light as the fact that the R line has a lot of the features that you would expect in a BRT service, such as namesake. It has branding, it has special stops, it has a lot of the other features that you would come to expect. And its ridership is about 9,000 to 9,500 a day, and it actually was the route that recovered the quickest after the pandemic, which continues to show the resiliency of that service. And it is the most frequent. Out of all of RIPTA's 58 routes, it runs every 10 minutes from 5 in the morning to 7 o'clock in the evening, and then every 15 minutes to 1 in the morning on weekdays. And then it's consistently every 15 minutes from start of service to end of service on weekends. So out of all of our service, it's the most robust as well. And so getting back to kind of the history of the project as it relates to decarbonization, we have been on this kind of ongoing process for years, going as far back as 2016, 2 years after the R line had started. And this was when a lot of agencies were starting to picking up smaller fleets of electric buses, not the larger numbers that we're seeing today, thanks to the IIJA and Lono program. But you'd see fleets of 10 and 15, not the 50, 70, 100s that are now coming out now. And so we decided before we would do anything pretty dramatic, we leased a couple of buses from another agency for a couple of years to measure a lot of the performance that you expect in a vehicle, whether it was the range of where the vehicle would go, the battery usage, the consumption levels, vehicle performance at large, weight distributions, and really get a sense of what this technology meant in perspective for RIPTA. Because unlike most operators in the country, we're one of only 2 statewide transit operators. So most have metropolitan areas that they focus on. I have everywhere as far north as Woonsocket and as far south as Newport. And so transition for us requires a lot more thought process than most. And as we started that initial demonstration in 2020, we learned rather quickly that we couldn't follow kind of the mindset that a lot of agencies were going, which was just depot-based charging, plug in overnight, pull out, pull in on a daily basis. I remember one such December morning, about a year into me being at RIPTA, a little over a year and a half, and it was a day in the teens, and we had put one of the 3 buses on the road, and its battery had dropped by 50% within 3 hours of being put into service. So instead of risking the vehicle dying on the road, we called it back, but it showed very conclusively that any transition for us really did require a more extensive infrastructure than just kind of taking the same path that everyone else had been taking. And at that time, we were demonstrating it not just on the R line, but we were doing it with the bus route that runs outside of our garage here in Providence, and a number of routes across the metropolitan area. And once that December day, and having run that vehicle on the R line a number of times, it became clear that we had to do inline charging, or else decarbonization was going to take a very, very long time, even for an initial phase. And it was also that time we decided that we also couldn't just rush and buy 25 vehicles in one go and then just hope for the best either. So we had made the decision to make our decarbonization effort as kind of a three-step process. One, being the R line. The second, having done a route, now doing all the routes out of the facility. We have a satellite garage in Newport that we're getting to gear up and get underway. And that facility and the vehicles that operate the services out of that, and then tackle the larger statewide situation. And so what we then decided was, all right, how are we going to get inline charging to work? Because most of the deployments, as far as I'm aware, and this is why I appreciate David, you kind of boosted my ego a little bit. Most of the inline deployments that I've known to date have been at termini locations or at locations where bus services are either in a pulse situation where they may have enough time in a holding pattern before moving on to their next job, their next trip. Fortuitously for us, in regards to the R line, because we were the successor of a number of private transit operators, just like most in the country, we acquired all the former land and assets of those agencies, including this particular parcel of land where we ended up putting our high voltage fast charging pantographs. It's a parcel of land right on the city line between Providence and Cranston. And we said, okay, at least the good news is for this deployment, we actually have it. And we knew going forward, it would be a little bit more challenging. And so we proceeded with the R line because we knew we had the land. We knew we could put the service together with the vehicle analysis that we had done from the initial pilot, and then said, okay, if we're going to do inline, we're going to be one of the first in New England and probably one of the first in the entire country for a facility of this scale. What does that consist of? And so, as you see on the screen, we went ahead and got 4 pantographs. Our original analysis showed that we only really needed 3 in active service throughout the service day, and there's a small peak in the afternoon between 3 and 4:30, and most of the day could be run by 2. But again, because the service runs every 10 minutes, because it has high ridership, because it's still new technology for us, we decided to kind of, like, some would say overbuild, but I would say in the name of redundancy, it's important to have additional infrastructure. And so when we were doing our electrical analysis for the utility, they had said, how much power do you expect to be consuming on a daily basis? And our analysis showed it was going to be about 1.2 megawatts a day, plus or minus kind of the ebbs and flows of service. And they were like, okay, well, we can't bring all 1.2 megawatts to you, and we can get you about 1 megawatt. And they said, even though we can give you the 1 megawatt, we would really prefer that you don't run more than 2 of the pantographs regularly. You can do 3 to do your peak, and if you had to do 4, literally run it, for 15 minutes or less. Otherwise, you're gonna cause an outage. And I was like, okay, that's a problem, because we know that there's going to be this instance where we're going to have 4 vehicles that are going to need a charge due to circumstances beyond our control. And so that's when we actively started looking at active charge management systems like what Mobility House is providing to us, to better understand and better regulate how much consumption we're bringing down from the pantographs, let alone balancing out the site. And so far, it's been very helpful. And the information has been very useful for us from a planning perspective, so we have a better sense of which vehicles are consuming more than others. Are there particular trips that we need to be more cognizant of? Are there particular locations where we're seeing consumption on the given route really draw down more of that battery than expected? And as we were putting the design for the site together, we also thought through, okay, we got the megawatt interconnection, we have the mobility house solution to regulate the charge flow at the site, but there's still the concern of just overall site redundancy and continuity of service. And so, you know, despite everything we put in, we still decided to put in a 600 kilowatt diesel generator. You know, obviously, some would say, why is it not using renewable sources? There'll be times where that develops. It's still really new. And we made the argument that the generator is really only for emergencies. It's not actually powering the site. It's only if, because the grid is connected to the wider Providence grid, if that was to go down, at least we could still run some level of acceptable reduced service so that the R line wasn't entirely shut down. Given that it's our intention to always be operating electrified service to the extent possible. You know, we still have our backup diesels in the worst case scenario if the backup generator still didn't work. But you know, we haven't had a need to run the generator, and you know, knock on, I guess, laminated wood here, shouldn't really ever need to run it. But you know, there's a general understanding with that. You know, insofar as kind of where we are with the R line now, you know, that service officially started being electrified in revenue service back in January, middle of January. And, you know, obviously we're still kind of working through the quirks of each vehicle. Every vehicle has its own kind of weird phenomenon to work through. But, you know, insofar as the infrastructure is concerned, what we're getting out of mobility house, not only the data of the consumption, but better being able to understand the health of the infrastructure on the site, particularly the pantographs, has been clearly helpful to us as we're still working through kind of software configurations and electrical configurations of some of the pantographs on the site. It's allowed us to better understand where the fault may lie, if it's really an electrical issue or if it's really more the pantograph itself. And without it, I would say we're probably would still be pointing fingers at a whole bunch of people and probably not getting a whole lot further along. But the last piece I'll throw out, and I'm sure Dana has a couple of other questions for me as well, is that the data that we have been getting from the pantographs has actually been very helpful to us in really mapping out, you know, the overarching service performance, because there are, you know, obviously there's general metrics of, you know, that you would do for any on-time performance related or vehicle performance. But because electrified service is still rather new to us, we still want to add performance metrics to that level. And so power consumptions, the time lengths, just kind of the historical trends at the vehicle level, merged with the array of vehicle performance data we're getting from some of the other software solutions that we have, is allowing us to build out a more concentrated and defined performance dashboard for these vehicles, and obviously for additional zero emission vehicles as we move forward. And it's been very beneficial to have that conversation, not just from a planner's perspective, but also communicating that with our maintenance teams and our transportation managers as well. And so, you know, obviously it's only been 3 months in service and there's a lot more to go, but you know, overarchingly, it's been rather successful. You're on mute, Dana.
Thank you. Sorry about that. Thank you so much, Zach, for that great background. I feel like that was so helpful. And it's been, as I mentioned before, just such a rewarding experience working on a project like this. I would say that really kind of the way that RIPTA has approached putting together this project is so unique. This is, you know, really the only site in the country that currently exists that has this exact configuration. So it's been super fun just kind of learning together, figuring things out, and collaborating with your team as we've put this project together. I will kind of jump in a little bit more about, kind of the energy management types of things that are going on at the site and how ChargePilot is able to work within these different parameters. And then we'll go ahead and jump into some questions at the end of the presentation. So first off, I do want to highlight just a few numbers here to kind of just show the configuration of the site and some of the constraints that we were working within that when we were designing the solution for this site. So the first one, Zach mentioned, there are 4 ABB 450 kilowatt pantographs on site, which totals to 1.8 megawatts of charger nameplate capacity. Additionally, Zach mentioned this as well, there is 1 megawatt of grid interconnection currently at the site, and then there is a 600 kilowatt backup generator on the site as well. And so when we were talking to RIPTA about deploying ChargePilot, the thing that was really unique about this site was that, on grid power, we have that 1 megawatt that we can operate within. But when that backup generator turns on, RIPTA really needed a solution that was going to be able to adapt to that more power constrained environment in real time and automatically so that, their site could continue to operate in those situations where there is a power outage. And so this was really the first type of use case that we had seen with this type of configuration. And so our team had collaborated a lot with RIPTA, Fuss & O'Neill, and Bond, who was the contractor for this project, to come up with a solution that would meet all of these different needs. So I'm going to revisit ALM again and just kind of give you a quick visualization of what this actually looks like, just to kind of help you visualize the loads and, kind of see what ChargePilot is trying to do. So this red line right here is the grid limit of the site. And so this is basically, the total power that is available, and this line can never be exceeded. Otherwise, we'd be pulling more power than what is currently available. And then this blue line here is the fleet load. So you'll see that, just kind of with this example screenshot that we have here, that as additional vehicles plug in, the fleet load will approach this red line, but it will never exceed it. And so what ChargePilot is doing in this situation is making sure that that total load is always respected and that is always electrically safe. And so, with this concept, this is basically the most kind of general ALM use case, right? This is on-grid power. You have 1 megawatt of power availability at RIPTA site, and you have 1.8 megawatts of charger nameplate capacity. And so basically that would be like kind of this first tier of ALM that we are providing at the site. However, with RIPTA's situation and that backup generator and having that more constrained power environment, it did require some extra thinking and engineering in order to figure out how to make sure that ChargePilot knows when that backup generator turns on. The local controller is really critical to this type of solution. Without having hardwired connections and hardware at the site, this solution would not be feasible. Since we're dealing with, physical components and physical infrastructure, it's really important that we have these hardwired components so that we can continue to optimize and take into account the real-time conditions of the site. And I will also add that this was a very cost-effective solution. And so basically by, doing kind of the system design and everything, we were able to, greatly minimize the capital costs of the site by allowing RIPTA to have, that lower powered generator and not have to, build big and, do those expansions that Zach had alluded to on the grid power. So by using automated load management, we were able to meet all of the needs of the site. And I think that this project is really just a great example of how collaboration between, RIPTA, our team, the engineering firm Fuss & O'Neill, and Bond, the contractor, really came together to allow us to have a really unique solution that works really effectively for all of the goals that we were trying to meet at the site. The last piece that I did just want to touch on really quick is the permitting process and how you can get something like this approved. So I mentioned before that the National Electric Code, or the NEC, does allow for automated load management, or ALM. The important thing to know here is that different states have adopted different versions of the NEC. So depending on which version you have, the language is going to be a little bit different. If you do have questions about what your particular state allows, you can definitely reach out to the Mobility House team. We do have policy experts, as well as our engineers are very up to date on the standards, and it would be able to kind of help direct you to the language that would apply to your site. For RIPTA, there's really two entities that were kind of involved in this. Zach talked about, the coordination with the utility, which is really critical for a project like this that is using ALM. And then there's also the authority having jurisdiction, which is the authority that will give you the permit for your site. And so honestly, in order to get the permit for the site, it was actually pretty simple. Our team worked with Bond Engineering, and we were able to provide them a cut sheet of our local controller, and then just a couple sentences about ChargePilot's functionality and how we would be controlling the load at the site. And with that information submitted as part of the permit package, that is how we were able to incorporate these ALM components and that backup generator integration into the project. Obviously, different authorities having jurisdiction and different utilities may have other requirements, but in this project's case, that was kind of our team's main role, was just kind of providing those two pieces of information. And that is everything that I have for the presentation. I think we can go ahead and jump over to some Q&A. So yeah, if anyone has questions, please feel free to put them in the chat here.
Hello, I'm Samantha Scheib with the Mobility House. Let me get some questions in. I'll read them out for Dana and Zach.
One question I have for Zach: how long would you say it took your team from like the planning and like initial design for this facility to when it got constructed?
4 years. Yeah. Well, no. 3 years. 3 years. There was 6 months of analysis work, but I don't count that as part of the planning because that was post initial pilot research, and that was going to happen anyway. So yeah, about 3 years.
Got it. And I guess another question that I have for you is, I guess what would you say was your biggest challenge during implementation, or I guess in terms of project delays, what were some of the factors or things that contributed to kind of the long development timeline?
I would say, and if my project manager, the project manager that I was working with on this was here, she and I would probably both agree that, a lot of the physical infrastructure wasn't hard to get, but it's a lot of the electrical components. Because again, we were building this during a major wave of the COVID pandemic. And so the switchgear was the thing that actually took the longest to deliver. Because obviously without it, you can't distribute the power to the rest of the site, let alone take the power in. So, we had a nice concrete site with a nice building, but we had no lights and we didn't have things running for many months. I think that took the better part of a year and a half just to get the switchgear at the time. I mean, I'm sure delays have come down, but it's definitely something to think through as you're building out projects on whatever scale you're doing.
All right, we do have a few questions, and I see that Emil, I believe, is also raising their hand. I could allow them to talk if we are okay with that.
Yeah, let's do it.
Okay, Emil, I think if you unmute, you'll be able to hear you.
Okay, great, thank you. And I guess this is a question for everyone, or Zachary, if you may be able to answer it. Based on your recent slide, you showed the diagram from the generator to the chargers, and how you're automatically adjusting the load. I wanted to ask, at your switchgear, what are some safety features you have built in? Do you have any EPOs that will shut power to the chargers from the switchgear or from the generator or from even the utility power source?
That's really more of a question that I would defer to the project manager, because she was the one very much involved in that side. But I can definitely get you some additional information. What I can say is that there's a rather robust fire suppression system that's been put into the site. You know, it's largely open air. The pantographs are outside. There's no indoor covering or what have you. But you know, the fire marshal at the state level, the fire chiefs in both Providence and Cranston were very clear as to what they wanted. And the mechanical room has a lot of, probably more than is regularly required for fire suppression, to say the least. From a technical standpoint, what I can say is, there are some things that are automated, like obviously the charge management that Dana's team has been working on with Mobility House. It's a little bit trickier, with a lot of the infrastructure, because at the end of the day, it's still very manual. You still do need to go into, the electrical cabinets of individual pantographs if you want to adjust settings in there, let alone go into the mechanical room of the main structure. Fortunately, and I'll have a project manager confirm this or deny that I was wrong. A lot of the electrical management systems of the generator are inside the building and not at the switchgear or the generator itself. So they're separated, but have actual connectivity from the mechanical room to the various pieces.
Okay, great. Thank you.
So we have a couple more questions. Does the solution include any type of power storage solution?
There is no power storage solution in this project. For our Newport project that we're only just kind of really getting in the scoping of, there has been some preliminary discussion of power storage or resiliency mechanisms. But just like with any project, there are a lot of them are customized and does require a better understanding of not only what is the use of it, but also what is the extent you're developing for, and what is the actual goal for it. Our continuity of operations for this site, is that generator. Some would say that, that's kind of a bludgeon, right? You just kind of smack a diesel generator on the site, but it's something that RIPTA is actively looking at. We know we have peers that are looking at it, but every single deployment is unique in design. You can't just pick up and drop the similar version that say, we have peers at RTS. If they did something, we can't just pick it up and drop it down. We have to configure it for RIPTA's purposes.
All right. The next question is BESS and PVDER something RIPTA is interested to add to their depot site, or was it ever considered?
If the person could just clarify, are they talking about the depot site as in this particular site, or the depot as in, RIPTA's main garages? Because I when I hear depot, I think garage. I just want to make sure I'm understanding. Just in the context of kind of RIPTA service, 90% of RIPTA's operations is out of the office that I am sitting at right now here in Providence, with the other 10% down in Newport. We are very grid constrained, just period. 95% of the grid is already being used, and any additional power to the site would be incredibly expensive and really hard to acquire. And that is a major challenge for us as we pursue our transition plans. I think just, for the two items you listed, we're going to have to look at everything, every approach and every possibility to make this transition work. Our contractors are definitely keeping an eye on it. I'm keeping an eye on it, as is our project management team.
All right. Our next question is there an estimation of the ChargePilot's impact in the power bill? And Dana, you might be able to contribute to this one as well.
But before you go, Dana, so it's a little early to say the power side, because the Rhode Island Energy is only just attached the power meter to the site. So I've got a couple of free months of power, which, thank you, Rhode Island Energy. So I'll probably have a better idea, within the next 6 months of, when we get to the summer, when we start seeing the summer utility bill. I think it will probably be about a year's worth of power before we'll really have a sense of what the trend really looks like. The general consensus I've heard is that, you know, with active management, you should be able to get pretty consistent bills, or at least, you know, you shouldn't see anything that's totally outrageous from the tariff. You know, fortunately, you know, because of our project, there are some incentives that were built into our arrangement with the utility. And that was part of a larger rate case across the state. You know, there's some infrastructure incentives that were put in. There were some rate reductions, or at least at the peak level anyways, just so we could start up and just get a better sense before we went full term. But from RIPTA standpoint, you know, the upcoming month is going to be the first utility bill where we're going to actually see power consumption and transmission levels and what have you. So, you know, I'm sure there'll be a chance for us to provide some better insight in due time.
Yeah, absolutely. And I guess the only thing I can really add there is I will say that, so yeah, there's definitely still the potential to generate savings for this site. I will say that our main focus, at least at the beginning of the project, has really been more on the automated load management, ALM kind of use case, making sure that we had all of the infrastructure set up to meet the site needs. As Zach mentioned, kind of as things change with the utility, we definitely can turn on some additional settings and do further optimization. But during this kind of stage, I think the top priorities were really working within the power capacity constraints of the site, and then also making sure that RIPTA had all of the data that they needed to be successful, as Zach talked about earlier.
Okay, we have at least one more question. So did ABB offer a fast charging option that charges via the J1772 port, or only overhead charging?
So Bond was responsible for identifying the hardware that would meet the scope of work and kind of the analysis that we had. They recommended the pantographs, and I concurred, and a lot of the team over here concurred, just because from a operational standpoint, because the pantographs can be called down by Bluetooth by simply switching essentially a signal generator on board the vehicle. The operators themselves didn't have to get out of the bus, plug in the cord, remember what time they plugged it in, remember to plug it out before they drove away, because they could just simply turn off the switch when they're done. You know, we baked into the driver schedules kind of roughly the amount of time we expected per, you know, every couple of trips when they would need to charge up. So there would be a comment saying, you know, I'll give one example of the trip that I'm familiar with. You know, say the trip that had the layover starting at 10:32, we'd say, you know, you should charge at this time. Your charge allotment is X number of minutes, typically between 15 and 18 minutes, depending on the particular trip, because that's, you know, it coincides with their layover period. And at the end of your layover, you will disconnect from the pantograph and just drive on your way. We also made it, we also went with the layovers because they were already at that location. We built driver restrooms at that site as well. So they actively didn't have to be engaged with the charging and monitor for themselves, other than just regulating their own layover. So it's just easier from that standpoint. I know there are plug-in solutions, but I think it comes down to every agency's kind of approach of how they want to deal with it. You know, we wanted to do charging at layovers. Some may decide, you know, we'll just do plugins at Doug Depot and we'll just do it that way. Every deployment's different.
All right, I think that's the end of the questions. I'm not seeing any new ones. So I'll hand it over to Dana to say some thank yous and some goodbyes.
Yeah, awesome. Yeah, thank you everyone so much for attending today, and a special thank you to Zach for participating. I feel like everything that you said today was super valuable and gave a lot of insights into how RIPTA developed this project. Please feel free to reach out to us if you have any additional questions, and we will also definitely be sharing the contact list with Zach. So if you do have any specific questions for him, or you know, want to reach out and set up a meeting, please feel free to do so. You can also reach out to us as well.